Hello YouTube, welcome to another video. Today we're going to talk about leetcode129, some root to leaf numbers. In this problem, we are given a binary tree. We need to traverse the tree. Each node has a number. We need to concatenate the number in this manner, and then sum up all the number we got in this tree. So let's look at the graph I draw on the right hand side. This is more like a augmented graph, just to show you that when we traverse the tree, what kind of calculation we need to do in order to achieve the final sum. So we will start from the head. So 4 here is the head here. We start from here. This variable accumulation is the place to store so far what's the result we have accumulated, and the final result will be the final output for this. So when we start from 4, this is actually the first node we discovered. This is a new node. Whenever we discover a new node, we will do this operation, time the previous accumulated number and then plus the local number. In this case, previous number is a 0, and the accumulated number will be equal to 4. Then, as DSF proceed, we will come to the left children following this arrow, and we come to this number 9. We start to explore this number, and this is again a new number. We repeat what we did as before. Use the accumulated number times 10 plus 9, and to get the new accumulated number. And but we haven't finished this part yet because this guy again has a left and right. So we will continue this arrow. Then we actually reach number 5. Um, Number 5 is also a newly discovered. So repeat this operation. After that, we realize, okay, number 5 doesn't have any children left or right. We kind of reach the end point. Then we will go back to number 9, and then start to proceed with the left children. So following this arrow, again we discover a new node and do repeat the operation for the newly discovered. But in this case, the accumulated number is actually equal to the accumulated number from the 9 level. It's basically 49 here as we calculate from here, because we already returned back to 9, and both children of node 9 will have the same accumulated number because that's what you inherited from the parent. When this is finished, we again go back to 9. At this point, we finish the exploration of a node 9, and we have calculated two values, 495 and 491 from left children and right children, and we need to sum them up. That's the operation when after we finish the recursive DSF. So that's why I highlighted with a different color just to indicate. And then same thing apply to this sum. After we finish the exploration of number 9, we have to go back to 4. And then in this case, again, both children will inherit the same accumulated number from their parents. So we have a 4 here. And then we will continue this path because that's the right children. In this case, the local number is 0. So we will use 4 times 10 to give the value. After we finish that one, there's no children anymore. Then we go back to 4 again. And now we finish the exploration of 4, and we need to sum up the value from the left children and the right children after the recursive. So this is the final result, 102. So this is basically the whole flow. Let's look at the implementation, how we're going to achieve this using the code. Okay, let's look at the implementation. I'm trying to associate the drawing from the left-hand side to the code on the right-hand side. So I will make a connection between them to explain this better. The first implementation here, we start with to define a function. That's a DFS function. We have a node, and then we have a accumulated number. So this is actually the input we got from the previous recursive call. And when we start this whole recursive procedure, and we basically call it in this way. So the node will be the root. In this case, it's number 4. That's the root we have here. And then the accumulated number is 0 because we haven't accumulated anything. So that's why we have a 0 here. And then with this call, we come to the inside of the DFS. We can actually see these as a 3-part. The first part here, that's actually the operation we need to do when we discover a new node. The second part here, that's the recursive part to further explore the children of the current node. And the last part is when we sum them up when the recursive call has been returned. So if we take node number 9 as example, then this node here, it will be number 9 with the value here. And the accumulated number here, it will be 4 because number 9's parents is the root, and the root's accumulated number is 4. So that's why we inherited it from the parent. What we do here is first to check if the node is valid or not. In this case, it's 9 is valid. We proceed to the next step here. That's the operation we did here to calculate the current accumulated number by time the previous one, 4 in our case, and then times 10 plus local number, and this is 9 here. After that, the ACC accumulated number will equal to 49, and basically we're finished the initial part, the first part. Then we come to the second part because we need to further explore the children left and right. So that's why we have a recursive call to the DFS function here with the node dot left. That's equal to node 5. And the ACC here will be 49 because that's the value from their parents. Same thing applied to the right node here, another recursive call. So this will be then equal to 1, and then this is again is a 49. So if you look at the call flow here, we start from 9, then we actually go to 5. This go to 5 error means calling the DFS. Then we actually go back to 9. When go back to 9, it actually means this location. So that means the DFS has returned. We are back to the DFS of the node 9. That's why we have this error drawing here, and it means in the code it means we reach this point after that. And then we have the next error here. Go to the right children. We will continue exploring that one, and that associate with this DFS call here. And then after that, we go back to it. So that associate to this line here means we come back again to the function handling the node 9. And after that, we want to sum them up. So this sum up will actually happen in the function number 9 level. So that's why we have this summation here to calculate the sum of it. So this is how this whole flow works. I hopefully this kind of drawing with the code will clarify how DFS traverse between the nodes. At least this is, I think, my personal opinion, this is more clear than only look at the code. I want to explain to you guys what those error means and in what phase we are we are associated to the code we have there, so that will then be more clear to understand the flow. That's all for today. Thank you for watching. See you next time.